is Moses, and I'm a special data scientist. So hopefully, I'm sure we'll have a good experience and value for our time and resources that we've committed into this training. Now, what is the expectation of this first course, which is SQL for data managers and spatial database? For this first course, we'll be looking at how to work with SQL, the concept and fundamentals of SQL, and then we can progress from manipulation of large data sets. Then at the end of the course, we'll be looking at real world applications, since the course is going to be practical oriented. So by the end of this course, it is expected that participants will be able to interact with their data set in diverse ways using SQL skills that we're going to be learning. Specifically, we'll learn the fundamentals of relational database management. We'll learn some terminologies in database and SQL, how to create databases, populate data, import data from various sources into our database, manipulate the data set in such database, and then we'll be able to carry out some analysis and insight from our data set. In general, we're going to learn how to ask the right questions, interact with our data set, and then we'll be able to provide intelligent insights, either from business research or organization data. Now, who should take this course? First, researchers and scientists that work with large data sets are actually recommended to take such courses with database so that they can manage their scientific data sets. Now, for those that are in the business sections, they are also expected to learn how to work with SQL so that they can interact with their business data and then come up with intelligent insights. Geospatial and built environment professionals like those in surveying, geoinformation, URP, geography, and related fields can also benefit from taking this course, since we can work with SQL in our GIS environment. New graduates that are thinking of a career shift in any data-driven role or considering moving into IT-related career, this course is as well for them. So graduates that are seeking a new area of specialization can consider this course. And then when you have individuals that have no prior knowledge or prior idea about relational databases and query languages, they can as well take this course and benefit from it. So what is the requirement for this course? For most of the participants that registered on time, I'm sure we all got emails guiding us on some of the requirements. Now, since this is a practical-based course, it is expected we have the required software so that we can follow as we learn. The idea of having 2 hours a week is to ensure that we have sufficient time to practice before we go ahead with the next lessons. So that is basically why we have to make it 2 hours a week. So the basic requirement is once you can set up your computer, you know how to install, you know how to look for applications, and that is sufficient for this course. However, for the second course, which is spatial database management, you will require some level of knowledge or level of understanding of spatial data, shape files, points, polygons, lines, and layers, and the likes. Okay, so but for this first course, regardless of your background, you will be able to benefit from it. So let's get started in a moment. Today's class is basically an introductory class to get us familiar with the concept of database and structured query language. Okay, so between today's class and the next class, for those of us still having challenges with the installations, hopefully we would have done all installations, because by next week we will need to start working on the software. So for today's lesson, basically we'll be introducing ourselves to the concept of database and structured query language. So what is structured query language, which is also known as SQL or SQL? Now, of course, we know that just humans have different languages, and then we also have different programming languages. Likewise, in computer terms, we have languages that allows us to interact with databases. Structured query language is actually one of such languages that allows us to interact with relational database. Now, the good news is SQL or structured query language is as close as English. That means you will be writing computer instruction or codes in a very familiar language, very similar to English. By the end of today's class, would have been familiar with some of the terminologies. So SQL is simple to learn because the statements are made up of descriptive English words. Now, SQL allows us to efficiently and easily create and interact with databases. It is simple to learn because the statements are made up of English related languages. So somebody is asking, I need details of customers from Spain. How do I get all the details of customers from Spain? And then at the end of this class, you'll be able to write such statement that will be able to retrieve such. For example, we have a statement on the screen. So we have a statement here saying select asterisk from customers where country equal to Spain. By the end of this course, you would understand what these statements mean. But for now, it means select, that means retrieve from the database, from the table. Asterisk here means all the columns. So when you have a table, you have different columns. So we're simply saying retrieve all the columns from customers table where the country name, country is Spain. In just these few lines of code, the database will retrieve all customers that are from Spain. So this is similar, or this is the kind of code you'll be learning in SQL, codes that are readable. Humans can read it and the computer can interpret it as well. So if you look at this, select is an English word. From customers is just the table name. Where is English, country equal to Spain is just a condition for the customers to be selected. So let's quickly look at database foundational knowledge, some basics about database. Now this is basically a review, as most of us would have at one point or other taken some courses in database, but for those that have not, just follow. I'm sure you'll be able to catch up. Okay, so let's do a quick run through some of the basic knowledge to help us learn better. What is data? Like I said, data is everywhere. So when we talk about data, we are referring to facts, figures, and statistics that are collected for the purpose of reference or analysis. Okay. Now, the value of data is evident after we have processed the data, and the outcome of such processing is what we call information. So the insight we get from raw data is what we call information. Data is everywhere, but it's information that brings the resources. It's information that brings the money. So when you go online, you see data everywhere, surveying data, spatial, non-spatial. Your ability to convert such data to information is what makes you a professional. Now we have different forms of data, and this can be classified either as numbers. So numbers are considered as data. It could be measurement, either numeric, continuous, or discrete measurement, survey measurement. These are considered data. Data could also be in form of graphs. Okay. Some could be in form of images like pictures. Some could be in form of audio. When you play music, that is a form of data as well. And some data set also come in form of videos. Okay, so all these are just examples of data. When you look around you, most of the things you see gives you idea of what data is. Numbers, measurement, graphs, images, audio, video. These are all data sets. When you sit at a junction and start counting the number of cars passing, that is already a data set. Now, but the insight you can bring from it, at the end of the day, you'll be able to tell the different categories of vehicles that are plying that road, the different categories of commercial public vehicles that you've counted at the end of the day. We've seen what data is. What is database? A database, in simple terms, is just an organized form of data consisting of one or more related items. Okay. So when you have data that are related, you have a database. It's simply like collecting data, which you can ask different questions. You collect your data form a database, and from the database you start asking questions. What are the number of airports in Nigeria? How many heliports do we have in Nigeria? Which countries have the largest number of airports? These are some examples of questions you can start to interact with your database. We want to know where are the locations of the 5 nearest bus stations to a particular school. From our data set, we develop a database, and from the database, we start querying to derive insights or information, as the case may be. Once you have a database, the system we use to manage a database is referred to as a database management system. So we use a database management system to control or to manage a database. In simple terms, a database management system is a set of software that handles storage, retrieval, updating of data in our database. For example, PostgreSQL is an example of a database management system that allows us to interact with a database. So we use the management system to interact with the database. As we see from our subsequent class, you'll be able to create a database, query it, update using a database management system. Now, why do we need a database? If you have a database, you'll be able to check some things. Duplicate value. So people cannot enter duplicate value, and then you quickly be able to retrieve information when you have a database. Let's take an example. Here we have data sets of team and the number of matches they won in the season. So just looking at this table, you'll be able to tell which of the team is considered the best team. How? From this data set, you discover that Team C will have won 35 matches. So if we go by the number of matches, automatically when asked which team is considered the best team for the season, we can easily say Team C because of the data we have gathered. So database will enable us to carry out data analysis as we have seen it in this example. Which country have the highest number of large airports? Which country have the least number of large airports? These are questions we can retrieve if we have a database, for example, consisting of airports data. Another reason for the use of database is to guide against duplication of data. So this will ensure accuracy in the database, what we call integrity of data. For example, once a column is defined as unique, it means we cannot have two values in that column. So if you look at this example, if this column ID is defined as unique key, automatically there are no two values that will be the same. A good example is your phone number, your account number, your BVN number, NIM numbers. These are unique keys, and that is why you don't have two persons that have the same number, either phone number, account number, NIN, or BVN. Okay, now they are able to achieve that because they have a database. So once a number has been assigned to you, the database will take note of it. Such number can no longer be assigned to a different person. But without a database, it becomes difficult to keep track of the IDs you have assigned and the ones you have not assigned. Likewise, for those in school, your registration number is also unique. So two students don't have the same registration number. However, assuming we want to use student's name as a unique ID, two students can have the same first name, the same surname. So it becomes difficult to use such kind of attribute to uniquely define an entity. When you want to avoid duplication, you must choose an entity that two of such cannot be the same. With database, we can manage such cases of duplication and avoid complexity in our data sets. Next, we want to look at relational databases. Relational database is simply a type of database that stores and provides access to data points that are related to one another. So it consists of related tables. In relational databases, we use tables to store this data set, and then we can define the relationship between one table and another. Let's look at example. We have a table here that stores the names and location of major cities, simply storing the ID, the city name, the latitude and the longitude of each city. So the table here gives us an idea of how relational databases operate. Data is stored in form of tables, and then different tables can be linked together. Here are examples of relational databases. We have PostgreSQL, you have SQLite, Maria database, Microsoft Access, interestingly, is also a database, the one that comes with our Windows operating system. We have Oracle database, MySQL, and the likes. Now, most of these databases, they use a common language, which is the structured query language. So we have a standard language that databases use, and then sometimes they may have some one or two differences internally. Now we decide to use PostgreSQL because of the next course we'll be considering, special database management. PostgreSQL has an extension called PostGIS that allows you to manage special databases. So Postgre is actually a conventional database or traditional database, and with the extension to manage spatial databases, so you can work with your shape files and the likes. Which organization or individuals make use of SQL, so that we know how popular SQL is? The International Space Station, they make use of SQL. Now it's quite interesting to know that SQL is being used by the International Space Station. Other examples include Skype, Netflix, Apple, Spotify, Dell, Facebook, Microsoft, LinkedIn, Stack Overflow. Now, these are examples of big organizations that make use of SQL. So let's quickly see some basic definition of terms related to relational database management. First is the concept of entity relation diagram, ERD. The ERD is simply a graphical representation of our database entities and the relationship between them. So in database management, a table is created for each entity. If, for example, we want to develop a database for a GIS unit in a state to manage their cadastral system, there will be a table for the client, table for the parcels, table for employees, table for transactions made and all that. So every entity is considered a table. And then we use the entity relation diagram to design the content of each table and the relationship between them. So for example, we can have an entity relation diagram for cities like we are seeing on the screen with various columns for our city table. And then we can have another diagram for population. It is this entity relation diagram that we now convert to table. So this shows one table called cities. The name of the table is at the top here, and then each of these, what we see here, will become columns in our table. What we are saying is there's going to be a table called cities, and it's going to have these following attributes: an ID for the city name itself, the latitude and longitude of the city, the country where that city belongs, ISO 3-letter character for the city. Now we have another table called population. So the table population is going to have 3 columns: an ID, population, and a GDP. If you look at the side of each of these tables, you will discover you have some numbers or digits in blue. The 1, 2, 3 here tells us that this ID is going to be a number, a numeric value. The ABC here tells us that it's going to be a string value. That means like alphanumeric name. The 1, 2, 3 here tells us that latitude is going to be a number, numeric. Longitude is going to be numeric. Country is going to be alphanumeric. It can take number or characters or letters as the case may be. And then the ISO 3-digit code is going to be alphanumeric as well. Now, if you look at the population table, You also see ID 1, 2, 3, meaning the ID is going to be numeric 1, 2, 3, as the case may be. Population is going to be number, GDP is going to be number. So this is what we call data type, as we'll see very soon. It is from this entity relation diagram that we translate to our tables. So first, you have the entity relation diagram at the point of designing your database, and then it's converted to a table. So if you look at this, the name of the table is cities. What you have here are now the columns, which you now enter the data. City ID 1, Tokyo. This is the latitude, the longitude. The country is Japan. The ISO 3 character name is JPN. Likewise, the population table. From the entity relation diagram, we now form the population table where we have the ID, population, and GDP. It is usually a good practice to design your entity relation diagram for each table in your database, so that when you come to creating the database, you will know exactly what columns and what data type each of these is going to be. Okay, so let's take a brief note on data types. Like I explained earlier, when you look at the side of this entity relation diagram, you will notice some numbers or characters telling us the type of data that is to be stored. So in a database system, it is expected that you know the kind of data that will be stored in each column. Let me give you an example. If, for example, you decide to store phone numbers or account numbers as numeric, like as digits, what happens to phone numbers or account numbers that have initial zeros? So that means for a bank that the account number starts with 003, for example, the first two zeros will be missing. By the time you go back to the table, especially in Excel, for example, when you store phone numbers as numbers, the first digit, the first zero will be missing. So you have numbers like 80, 90. Now, because we know that, okay, the first number is 0, it's easy to correct. But for account numbers, you will not be able to tell if it is 2 zeros or 1 0 that are missing. So when you have numbers that you don't intend to carry out calculations with, it is advisable you store them as alphanumeric. So phone number, since you're not going to be calculating average of phone number, maximum phone number, store it as alphanumeric so that it can preserve the initial 0. When you have account numbers, you are likely not going to be carrying out calculations with account numbers. So you store them as alphanumerics, what we call character. But when you have age, for example, age is something you can store as numeric. Latitude, longitude, GDP, anything you are likely going to carry out computation or statistical analysis with that is a number, store it as numeric. But when you have numbers that are just IDs, phone number, account number, BVN, you store it as alphanumeric to avoid losing the initial zeros. So let's look at this. These are what we refer to as data types. Now, these are examples of data type: numeric, character, date and time for storing date and time, monetary, binary, Boolean for storing values that are true or false, geometric, like we'll see in our special database management, text, and so forth. So you have different data types, and it's very important you define the data type for each column of your table. Next is the concept of primary key and foreign key. When we refer to a key is simply a column that allows us to uniquely define a record. So a primary key is that column or combination of columns that uniquely defines a table. A foreign key is simply a primary key of one table, which is used as reference in the second table. The two tables are therefore linked by a foreign key. Let's explain. Now, a primary key is that column that uniquely defines the records in your table. I gave an example earlier. If it's for a school, a primary key is likely the student registration number because no two students have the same number. For bank, account number can be used as primary key because no two customers have the same account number. For the government, they can decide to use your BVN or NIM as primary key. So when they want to uniquely define each individual, they use your BVN or NIM. That is primary key. Now, when two tables have primary keys, for example, for city table, we have primary key referred to as PK. So this is the primary key for city table. Here is another table called country, and each country has a unique ID. So that gives us a primary key for country table. But take a look. When you look at the city table, for each city, we state the country ID where that city belongs. Country table also has its own ID referred to as the primary key there. And for each country, you have the country name, you have the currency and the likes. So country ID in the city table becomes a foreign key. So a foreign key is primary key in another table that is being made reference to. This table belongs to city. So the column that uniquely defines city is the primary key here. So if we make reference to another primary key in another table, let's say the country table, that primary key in this present table becomes a foreign key. When you're in your house, you are the landlord. You go to somebody's house, you become a visitor. So the primary key is like the landlord. The foreign key is somebody that is landlord somewhere that has gone to somebody else's house. Okay, so we'll understand this concept when we come to joining table, because here we don't want to write all the details about the country under city table. Otherwise, our table is going to be unnecessarily large. Imagine if we have to put the country name, the currency, the official language, the country code. This city table will become unnecessarily large. So all we need to do is just put the country ID. And then if we need more details about the country, we can use the ID and access the country table where we get this additional information. Okay, so this is one strength of database management, whereby you can link tables together. We have a city table, we just put the city ID. If we need more information about the particular city, we use the country ID to access that information in the country table. For school, let's assume you have a table for test course, for a particular course. All you need is maybe the student name and reg number. Sometimes you don't even need the name, just the student registration number and their score. Now, if peradventure you need more detail about a particular student, maybe the student is not doing well, you want to see the course advisor, all you need to do is use the student ID, access the student biodata table, and see all the information about such a student. Okay, so that is basically the concept of primary key and foreign key. Primary key is the key that uniquely defines a table. Foreign key is another key that uniquely defines another table but is being made reference to in the current table. So what are the basic differences between primary keys and foreign keys? Let's take a look at some of the differences. First, a primary key attribute in a table can never contain a null value. Remember that that column that we define as primary key must uniquely define a table, so it cannot be null. For example, a student, we shouldn't have a record of a student that don't have a registration number. A bank should not have a customer that don't have an account number. Because if you have two people that don't have account number, it means they have the same value under account number, which is null, empty. So a primary key can never be null. Immediately you define a column as primary key, what you are saying is that that column will uniquely define that table, so it's going to be unique and it cannot be null, cannot be empty. On the other hand, a foreign key may have null values as well. For example, We can have a city that we don't have the ID. So we have a city that we don't have the country ID. In that case, that country ID, which is a foreign key, can be empty. A primary key in a table cannot be empty, but when that primary key becomes a foreign key in another table, it can be empty. Next, not more than one primary key is permitted in a table. Okay, so you should have just one key that uniquely, once you have one column that uniquely defines each record in your table is sufficient. If phone number will uniquely define everybody in this group, that is sufficient. If we need more information about each person, we just go to the phone number and we get that. So we don't need to say, bring your phone number, bring your NIN, bring your BVN, account number. As long as one entity is able to uniquely define each individual, that's all. So you can have more foreign keys, but your primary key should just be one column. Duplicity is strictly prohibited. That means you cannot have duplicate value. That is what makes that column a primary key, the fact that you cannot have duplicate value. But for foreign key, it's possible to have duplicate value. In the same table, a city can appear twice, and then each time that city appears, the country ID for that city will also be in that table. Primary keys cannot allow duplicate value. That is why it's primary key, but foreign key can have duplicate values, as we'll see. The next is the concept of constraint. Constraints are more like limitations or rules we set to guide our database. The first example here is not null. Not null simply means that that column do not permit empty values. So a column that is having a not null constraint set on it will not allow null values, but it can accept duplicate values. What we are saying is that column should not be empty. There are times you fill a form online and you will see they will tell you some of these fields are compulsory. Your first name and maybe a last name, but you discover your middle name is optional. For example, your first name can be set as not null, meaning every participant must enter their first name. But middle name can be left as null because not everybody has a middle name. Then surname can be not null, meaning there should be a value. So when you are collecting data for your database, at the process of designing the table, you must decide which information should not be null. That means that information must be entered in your table. So depending on what you are designing, it will determine which columns should be null and which column should not be null. So ensure that a column cannot have null values, where null means missing, unknown, or null not applicable values. Okay. A student database, the registration number must not be null. First name and surname must not be null. Middle name can be null, can be optional. So what you call optional when filling form are null values. Those information when filling a form that you see asterisks that are compulsory, it means they are not null. So you have to enter such. Then you have what we call unique. Unique means that all the values in that column must be different, must be distinct. A primary key actually combines these two properties or these two constraints, because a primary key will not allow null value and each value must be unique. So I hope we get it clearer now. So a primary key is actually a combination of not null and unique. No value should be empty and each value should be unique. A default value simply specifies a default for the column if no value is provided. A good example is when filling a form, let's say the form is for Nigerians, or rather the form is mostly for Nigerians. And then under country, we can put a default value of our country, Nigeria, so that since most people filling the form are from Nigeria, once they get to that place where they are supposed to enter country, they would have seen Nigeria waiting. If they are not Nigerians, they can easily click and change it. So a default value is a value that is set automatically if no value is provided. Another practical way of using default value is setting the date that the data was entered in your table. So you can put default. By default, you put the current time. So if the person entering the data did not put the time, the database will automatically pick the current time as the default value. So when designing a database, you ensure that if there are values that can be provided by default, once no value is entered, then you specify that this is the default value. Immediately that value is not entered, the database management system will pick the default value and assign it to that record. Okay, we've talked about primary key, which is a combination of not null and unique. We've talked about foreign key, so we can move to the next item. Check ensures that all values in a column satisfy certain conditions. Now, as the database administrator, when designing your database, you want to put some kind of check to your work. Let's assume a form is meant for only adults from 18 years and above. Automatically, you can put a check that if the age is less than 18, you should reject the entry. That is example of check. If you are carrying out your work, maybe latitude and longitude in Nigeria, you want to put a check to ensure that a user do not enter a longitude and latitude that more than 2 to 15, 2 to 15, for example. Once the location is outside that range of latitude and longitude, the database will reject it. So you use check to ensure that values are entered and validated at the point of entry. Otherwise, you have so much data to start correcting and pre-processing. So these constraints are ways that you reduce the amount of work you have to do when collecting data. If there is a check on age limit, you define it, so you don't have to start screening out those that are not within the allowable age. If there is a default value that should be there, if no value is entered, you specify it. So let's see example of a database table. In database terms, a table is also referred to as a relation. So that is why we call it relational database management. So when you see us say relation or table, we're referring to the same thing. Now, the columns in a table are referred to as attributes or fields. This is a familiar term in GIS where you hear attributes, the properties. If you are storing record for rivers, what are the attributes? Maybe the length of the river, is it a major river and all that. If it is a road, what are some of the attributes? The length of the road, the class of road, major road, minor road. So each of those attributes are what becomes columns in our table. That is why columns are referred to as fields or attributes. So when we say columns or fields or attribute, we are referring to same thing. So for the city table, the attributes are the ID, city, latitude, longitude, country, ISO 3, population. These are also referred to as fields. So either you call them fields, attributes we use mostly in GIS, or columns. The rows, on the other hand, are referred to as tables, tuples, or records. So we refer to the rows as record or tuple, meaning each row is a single record. For this table, for example, it means we have 6 records because we have 6 rows. Okay, and then we have 1, 2, 3, 4, 5, 6, 7 fields, 7 columns, or 7 attributes. Attributes are basically the information you want to store about that entity in your table. This is city, and what we are interested in is the ID of the city name, the location, the country, the ISO 3 code, and the population of the city. If we're interested in GDP and other attributes, then they become fields in our table. Okay, so let's take note when we hear the term attribute field, we are referring to the columns. When we hear the term records or tuple, we are referring to the rows in our database. So the number of columns in a table is referred to as the degree of relation. What are the steps we take when we are designing a database? We've seen briefly what a data is: numbers, charts, measurement, pictures, audio, videos. We've seen what a relational database management system is. We've seen what a database is. Now, how do we design a database? What are the practical steps? If after this training you decide, okay, I want to design a database for my survey office, I want to design a database for my clients, what are the steps you will take? I can have a database for client, so you know the name of the client, his phone number, the job he has done, and then at the end of the year, you want to reward your client. You can easily search and see which clients have consulted you the most times. So what are the practical steps for designing a database? The first step is to gather the required information. In gathering the required information, you need to consult with all the stakeholders involved. What is the information we need? Once you gather the information, you identify the object. Information about what do you want to store? I want to store information about my employees, about my transaction, about my clients, and all that. So each of these becomes an object. And as you continue, you discover each object will form a table. So every entity you are interested in storing data about will be identified before you start designing your database. Next, you move to designing the database itself. You identify the type of information for each object. You identify the relationship among the objects. You manage the database using a database management system. Like in our case, we intend to use PostgreSQL. So the first step is gathering information. In gathering information, what do we need to do? You may have to interview every stakeholder involved so that you can identify what they want the new system to do. Then you identify the problems, limitation, and bottlenecks of existing system. What is the problem with the existing system? Maybe they are using file, manual system, and then there is limitation. Data can get destroyed at any time. It becomes difficult to retrieve. Imagine you are in a ministry and they ask you to retrieve all survey plan for people between the ages of 30 and 40 that are from Kaduna State and are civil servants. So imagine how long it will take, and maybe all these files are put together. First, you have to start searching those from Kaduna State. You start separating those that are civil servants, start separating those that are between 35 and 40 years and the likes. So you need to identify the challenge or challenges of the existing system. So once you interview everyone involved, you sit down, have a roundtable discussion about what is it you want. You identify what the new system or the database you want to do will do. You identify the limitation of the existing system. Then you can start collecting copy of existing file system. For those of us that work in most of the GIS setup, you discover they will want to collect existing survey plans, the hard copy, okay? Because this is part of the step. Collect copies of existing file data, reports, and any other document that are part of the existing system. So once you gather all that, you can start thinking of coming up with your own database. But first, it's always important to collect existing data because most likely you have some data on ground that you're going to be working with. The next step is identifying the objects. Now, identify the key objects or entities that will be managed by the database. Now, this object can either be tangible objects such as parcel of land, person, product, or even intangible objects, for example, account details, transactions. These are intangible objects that we can collect data about. Once you identify the object, either tangible or intangible, the next step is to model the object, whereby we record the object in a way that represents the system visually, using, for example, the entity relation diagram we talked about. The next is to identify the types of information to be stored for each object. For example, we want to store pieces of information such as name, okay, determined by a source of external database. It could be categorical columns where you have a group, male, female, gender, true or false, married, single, or an identifier that provides unique identity. We also want to find out the relationship between these columns. Is there any form of relationship between the columns or between the tables? These are what we do at the next step. Identifying the relationship between the objects will determine how they logically relate. Where necessary, we can add additional columns that establish a link from one table to another. Now, once we are done with that, the next step is to design and manage the database. We can do that using our knowledge of SQL. We can implement such design. So by the time we're done with this course and we know the language SQL, we'll be able to create a database from scratch, bring in our data, manage it, and then query our data to retrieve different insight or provide answers to different questions.
Hello, good afternoon. Yes, sir. Good day, sir. Thank you so much for the presentation. So far, it has been wonderful. Getting to learn one or two things a lot, and it has benefits. It's benefiting me. And straight to my question: after creating a database, is it going to be like from what so far the installation of the software we know is going to be on our laptop, on our system. But
Yes.
let's assume I'm not. Is it, can it be operated from anywhere? Like I can log in online and do my updates without really being with my system. That is, I mean, the database now, can it be updated without manually being with my system?
Yes, you have provision for such. We encourage cloud computing, that you do everything
Yes,
from cloud. Okay, so
yes.
you can have your database online on the cloud,
Okay.
whereby you do everything on the cloud. Most of the forms we fill, where you fill in your data, they are databases and they are online. Okay.
Yes.
Now, another good thing about structured query languages, you're going to be writing instructions in English format for the database. Now, if you store that information, anywhere you run that set of code, it will generate everything contained in your database.
Okay.
So by the time we start the practical section, you'll be advised to save your instructions. If I say create database and I give it a name, I import my data and everything, that logical steps that the instruction is given, once you run it, it will replicate everything. So sometimes when we say you are backing up your database, what in some cases they are saying is you are saving the instructions that created that database. So at any point in time, you can rerun it.
Okay.
Yes.
Okay. Thank you, sir.
Thank you. Any other question? We'll have a recap, like some person said, and then please you can put your questions in the WhatsApp group even after the class. We have a whole week to discuss what we have covered. That's the idea. So between now and the next class, whatever questions we have should have been taken care of. When we start the practical section, 1 week is enough to practice over and over. Okay, because we are going to be learning a new language. So the more you speak it in form of practice, the more proficient you become in the language. Database foundational knowledge. First, we talked about the fact that we'll be learning a language referred to as structured query language, which is a more like a universal language used for interacting with databases, including Oracle. Okay. Now, for we that we are in the geospatial field, we have an extra work to do because first you have traditional databases like your Microsoft Access that those from computer science and other professionals can easily work with. But we also have an additional work to work with special databases. And we know that once you bring in the special components into your data, so many additional analysis can be done that your ordinary traditional database cannot take care of. Okay, we'll see this in play, but let me give an example. If I ask from your data set, where are all the heliports in Nigeria from a data set of airports? we're asking where are all the heliports in Nigeria? You can easily run a query and then you see all the heliports in Nigeria. However, when you bring in the special part whereby you plot the location of those heliports using your special database, you'll be able to see how these heliports are distributed, and you know that okay, most of the heliports are in the South region. Why? You start thinking why? Because most of them are owned by oil company. So you see the heliport, you go to the column for name and all that, you'll be able to tell, oh, most oil companies have heliports because they just want to pick their expatriates and then land them where they want. Bringing in the spatial component is one of the things that distinguish you as a spatial data scientist, at least a potential one, from a conventional or traditional data science scientist, because you have an additional sense, the spatial sense, added to your analysis, which makes a lot of difference. Okay, so that is the language, and like we said, it's a language that is quite similar to English language. You'll be writing statements that you are very familiar with: select, where, customer, country. So it's a language that is so close to English that as you practice it, within the next 2-3 classes that will be meeting, you start conveniently speaking the language itself. So this is not like the conventional programming language where you write a lot of code and it looks very difficult. No, here you'll be writing as if you're writing English. We are simply saying bring out asterisk here, we'll see very soon, means all those columns, all the attributes. If I'm only interested in the name and phone numbers of customers from Spain, I will say select, and then I will specify name, comma, phone number from, this is just the table name, customers table. And then there is a condition, we only want customers from Spain. So we'll say where the country is Spain, country equal to Spain. So this will retrieve the information about customers that are from Spain. This is just how SQL works. English, convenient and easy to speak. We talked about the concept of data. That what is data? Data is everything that you are interested in. It could be numbers, it could be measurement, okay, it could be graphs, it could be pictures, images, audio. That entity you are interested in is referred to as data. And then database is when you now have collection of data that are related. That gives you a database. So database is just a collection of data that are related. The online form, for example, that you filled for this training can be made a database. I can now start querying based on the information I've collected. Now, because I did not ask for state of residence or state of origin, I cannot tell you the number of participants from each region. So if originally I'm interested in knowing, okay, I want to know the distribution of participants across the YSN chapter, then I would have created a field for state of residence or state of origin, and then I will be able to carry out more further analysis. So if you don't design your database from beginning and then needs to do some analysis, it may warrant you going back to recollect your data. That's why it's very important. It's better you have excess data, what we call redundant observation in surveying, whereby you have more data than you actually need, than to have data that is not sufficient. When you have excess data, you can easily ignore, truncate, or remove the ones you don't want, filter out the ones you want. But if you collect data that is insufficient for the analysis you want to perform, it becomes very expensive because you may have to go back to site. That is why it's very important to discuss with all the people involved. You want to do a GIS cadastral system for a state, you have to discuss with them what is it they want, what information do they want to collect, what form of analysis do they want to carry out. That will guide you on the data that you will collect, and then you design your form and collect the adequate data. Okay, so database is simply collection of data that are related. And then once you have a database management system will allow you to manage a database. So it will allow you to create a database, it will allow you to create the tables in the database, it will allow you to define any form of constraint. in the database, it will allow you to import data into the database and even to query, retrieve data. Where there are mistakes in the database or there's a change of value, you want to update, somebody has changed his state of residence, you want to correct, the database management system will allow you to do that. Why do we need a database? Now, government, for example, may maintain a database of their infrastructure, let's say health facility, a survey office may want to maintain data about their land parcels. A business firm may want to maintain data about their customers and supply. A taxi company, for example, may want to keep record about their riders, like Uber, Bolt, and all that. They keep records so they can carry out analysis. They see where you have more traffic, they see where you have more subscribers, and the rest. The database will also allow us to carry out data analysis. As we'll see from next week, we want to see the relationship between the data set. On this table, for example, all we have is the team and the matches won. But what are some of the analysis we can carry out? We can now see the best team. If we have added goals and other information, you'll be able to predict and say, okay, based on this performance, this is the best team, this is the worst team. Like from this table, the worst team is this. So how do we know that? Simply by looking at the number of matches won. If we sort this from highest to lowest, you will be able to see that, okay, this team have won only just 15 matches. So a database will allow you to carry out data analysis, query, and answer questions that ordinarily, by looking at your data set, you will not be able to answer it. Where you have data that is having over 100,000 rows, and then you are asked a specific question, how do you answer that question? By scrolling through the data. That is why you need a database. Furthermore, a database will assist you in avoiding duplicate values by defining some constraints. Here we are giving an example of a unique key, that this column has been defined that it should be unique. So by defining it to be unique, automatically you cannot have duplicate values. With a database, we can say, okay, let there be no duplicate value. Automatically, once an ID has been assigned, you cannot assign that ID to another person. That will save you a lot of stress. And I gave example, account numbers are unique because everybody has a different account number. Phone numbers, and that is why when you lost your phone number, they can assign it to somebody else and you will not be able to have access to it, because two persons shouldn't have the same phone number. Your NIN, your BVN, these are unique values that can be defined to avoid duplicate values. So a database help you to avoid such duplicate data set. Then we'll talk about relational databases. Relational databases are just normal databases that store their record in form of tables, or what we call relations. So when we say relational databases, relation is also known as table. So a database that stores its data in form of tables, rows, and columns is what we refer to as relational database. A database management system is used to manage a database. Likewise, a relational database management system is used to manage a relational database. And we gave example, PostgreSQL, SQLite, MariaDB, Microsoft Access. These are examples of relational database management system that store data in tables. Next, we gave example of major organizations that make use of SQL, and it's interesting to know that International Space Station is one of them. No wonder learning SQL can actually skyrocket your potential, because even the International Space Station is powered by SQL. Other big organizations that we are familiar with, they make use of SQL. So SQL is not old school, okay? The basics of relational database management. What are the basics? What are the things we need to know? We need to know how tables are organized in a database. And we say we use entity relation diagram just to give us idea. Of course, you can design your database without this diagram, but the diagram will help you visualize how your table will look like when you're done. So we gave example of two tables, a table called cities to store data about cities, and then another table called population to store data about population. And we say based on this entity relation diagram, we can automatically translate it to a table. How? Each of these fields or attributes or properties translates to columns in our table. So ID becomes a column, the city name, the latitude, the longitude, the country, and the ISO 3-character code for the city. Likewise, our population table, each of these becomes a column. So if I ask you, design a table to store the location of, let's say, farmland, you have to decide what will be the contents, what should be the attribute of the farmland you want to store. Maybe the ID, the owner of the farmland, the location of the farmland, the perimeter of the farmland, and other details. So your entity relation diagram help you to visualize how your final table will look like. We said something, we have different form of data, and each of these data can be in different type. A data can be numeric, like numbers, for example, ID, age, weight, height. A data can be characters, like alphabets, for example, city name, or it can be alphanumeric. Likewise, your latitude and longitude, for example, they are numeric. Country, you use character to save it. So it is important to know the data type that each column in your database is going to store, because you decide that at the point of creating the database, even before you start entering your data. Otherwise, you have issue. And I gave example of Excel when I say if you store phone number in Excel, for example, and you say phone number should be numeric, that first zero, initial zero, can be lost, because when you say 08, numerically 08 is 8. If it is account numbers you store as numeric and the person's account is 003456, because you say it's numeric, 003 mathematically is the same thing as 3. So the first two zeros will go. But that has lost the meaning of that data set, because it is an account number and is not complete without those two initial zeros. So I advised that when you are storing any numeric data that is not for calculation or for any statistical analysis, it's better you store it as character, or what we call strings, alphanumeric, so that it will retain that value. Let's see if we can have a brief demonstration. Let's assume this is defined as number, and then I want to store account number 003456. Press enter. Let's remove this. By the time I press enter, can you see that the initial zeros are gone? And this, when you try to send money to this account, automatically the money will bounce back. The person will not get the money. But now let's define this second column as text or string. By the time I type this same 0034586987 and I press enter, can you see it has retained the initial zeros? Though it is a number, we save it as text to preserve it the way it is. Likewise, phone number 0802356. Immediately you press enter, the initial zero is gone. Well, this is a bit bearable because we know most number begins with 0, okay, 081, 080. But if we store the same number as a string or as text, then the initial zero is maintained. And that is why I advise, if you are not going to carry out a computation with any number, especially numbers that have zeros at the beginning, it's better you save them as strings, as text, so that you will preserve the complete data set. Once you define a table, it is necessary to define the type of data that will be stored in each column. Name, for example, is character. Phone number should be character. Age should be number, numeric. Weight, numeric. Latitude and longitude, for now, numeric, but very soon we'll see that when we come to special databases, there's a way we define locations. Okay, so once you create the columns in your data, or what you call fields in your GIS environment, define the type of data that will be stored. Will it be number? Will it be character? Will it be date? Will it be time? Will it be money in form of currency? Very important. Then we talk about the concept of primary keys. Primary key is we're simply saying in your table, you should have a column that can uniquely identify a record. And I say if you're using somebody's name, you want to use name to define each individual. Then you have people that both first and second name are the same. That means name cannot be used to uniquely define that set of people. Or you can use things like registration number, or you create a new ID and everybody has an ID that uniquely define each person. So that is the concept of primary key. Foreign key is also a primary key in its own table, but that it's now being referred to in another table. That makes it a foreign key. City table has a primary key called ID that uniquely define each city. And then for each city, we have a country ID here that can tell us more details about the country where that city is located. So the country ID has become a foreign key, while in the country table, the ID there is primary key. If we refer to that ID in another table, it becomes a foreign key. Why do we need that? So that we can connect one table to another. Instead of having all these details here, the country name, the currency, all attached to city, all we need is just give us the country ID. If we are interested in knowing the currency, the country code, or any other detail, we use that country ID and access the table that is storing information about the countries. So that is the concept of primary and foreign keys, to allow us connect from one table to another, link them and get more details, so that you don't have one table that has so many columns. Okay, so this is example of a database table, and then we try to define some terminologies. We are already familiar with columns from Excel, but we are saying that these columns are also referred to as either fields or attributes. So when you have a table, the different information you want to store about that entity in the table are what we refer to as attribute, fields, or column. Now, the information about each entity, what we call rows, are referred to as either record or tuples. So for this table, we have 6 rows or 6 records or 6 tuples, while we have 7 columns or 7 attributes or 7 fields. Then we quickly looked at database design step. What are the steps we follow when you want to create a database? If after this class you decide that, oh, I want to create a database for so thing, what should be the step? First, you have to gather the required information, very important. When you gather the information you want, you identify the object you want to store the information about. Is it about clients? Is it about land? Is it about student? Then you design the model in terms of entity relationship, define each table, what information will be stored and what type of information. Should the information be numbers? Should it be character? You identify the relationship between the table. For a bank database, for example, you have information about transaction, account, details. And there's a relationship between account owner and transaction, because account owners can perform multiple transactions. So that is what we call one-to-many. If in school, you can have one student being taught by different teachers, that becomes many-to-one relationship. Once you define such relationship, you implement the database and manage it using a database management system or a relational database management system, as the case may be. And then we try to explain each of the steps. That's what we did, which you can easily go through. Once you are at this point, we're happy to tell you that, well, you are now set to begin learning the language of database, which is actually the structure query language. So if you understand what we have done from beginning to this point, I can tell you you've taken a very big step towards spatial data science, because the first part of data science, either spatial or traditional data science, is your data management, which is what we are dealing with in this course. And this first meeting has been able to establish some of the basics. For some of us, it's a reminder. For some people, the new concepts that are introduced you can quickly go through and get more details within a space of 1 week while you try to complete your installations. Okay, so once again, I want to thank you and still ask if you have further questions, let us know here, or when we go back to the group, we can discuss in details. Yes, any further questions, comments, contribution, or observations? I see your hand is up. Please go ahead.
Yes, thank you, sir. I have a question.
All right.
My question is in the database where
Yes, sir.
let's assume I want to import my coordinates,
Yes,
X, Y, Z coordinates. Do I,
yes.
is it possible, sir?
I'm with you.
Okay, I say, is it possible to import them to update them in the database directly, or I will have to input them manually?
That's a very good question. Let's
Okay.
assume, let's assume you are to impute them manually. You enter each one at a time.
Yes,
What if you have a million coordinates?
exactly.
So we'll learn how to do the manual input, but more importantly, we will learn how to import, because sometimes you already have, for most database or databases that you'll be creating, in most cases the data is already existing.
Yes.
So you will learn how to input manually, but more importantly, you will learn how to import them into your database environment. So you will be importing and you'll be entering manually.
Okay.
All right.
So another question.
Yes, please.
Let's assume I have a model, existing model that have been active for a while, and say a
Yes.
year, and there is a need for me to carry out an update or change the model.
Yes.
Am I going to restart the to design the model all over again, or I can easily update and go back to my code and do the necessary updates?
Okay. Now, um, I think in our next class or so, you will discover that under the structure query language, we have different set of languages. We have the ones that allow you to modify. We have the ones that allow you to query, just to retrieve. So
Yes.
those language, the part of the language that allows you to modify can actually enable you to modify existing model. So you don't have to
Okay.
create from scratch.
Okay.
But don't forget, if you modify an existing model and there is information that is missing, it will not be imputed automatically. You have to collect it and then add it. If, for example,
Okay.
in the existing model, phone numbers were not collected, your
Yes.
database can allow you to now create a column for phone number. But because these phone numbers were not collected, you have to collect them, then the database management can now add them to the respective columns.
Okay.
So that is why it's important to have a good model from beginning. So imagine your workers have gone, or clients, and then you start looking for them to provide phone numbers when you would have collected it at the point of collecting other information.
Yes. Yes.
Okay.
Okay. All right. Thank you, sir.
We'll take other questions from the group. Thank you very much